a solution containing 2.75 grams of cobalt chloride, 6 ammonia, right? So what is the weight in grams given over here? So weight in grams is equal to 2.675 grams, right? What is the molecular weight given over here? That is 267.5 gram per mole, right? Now this is passed through a cation exchanger, okay? The chloride ions obtained in solution were treated with excess of AgNO3. It means I am passing, say, this particular cobalt chloride, that is COCl3, (6NH3). Now this is passed over what? The cation exchanger. And due to which what was obtained? The chloride ions, right? Now this chloride ions were treated with what? AgNO3. So what will you obtain? You will obtain AgCl, right? So the amount of chloride ions liberated will be equal to the amount of AgCl formed. So how much of AgCl is formed over here? It is 4.78 grams of AgCl formed, and its molecular mass is 143.5. Now what do you have to find out? The formula of the complex, right? What it is asking, what is the formula of the complex? That how many Cl atoms are outside, right? Because the weight of the formation of AgCl, the weight of AgCl formed is equal to the number of Cl ions which are produced by ionization, right? So now let's solve this question. What should be our thing, students? Let's find out the number of moles of Cl liberated, right? Now that will be equal to the number of moles of AgCl formed. Okay, or let's find out the number of moles of complex first. Okay, so your number of moles of complex is equal to how much? Your weight in grams, that is 2.675. Number of moles of complex is 2.675, and that is divided by 267.5, and then it gives you 0.01 mole chloride, right? This is the 0.01 mole of complex, right? Okay, now the number of moles of AgCl formed will be equal to what? The weight in grams of AgCl, that is given as 4.78 grams, divided by the molecular mass, that is 143.5, and this is equal to, let's find out, it is 4.78 divided by 143.5. Now this will be 0.03 moles, right? So 0.01 mole of complex. So your 0.01 mole of complex is giving how many moles of AgCl? 0.01 mole of complex is giving 0.03 mole AgCl, right? That is, this of now moles of AgCl formed moles of silver chloride formed are equal to the moles of Cl ions released from what? From the complex. Right? Now, so if 0.01 mole of complex is giving 0.03 mole of AgCl, so 1 mole of complex will give how many moles of AgCl? 0.03 divided by 0.01. So it is giving 3 mole AgCl. It means 3 moles of Cl minus are liberated, right, as ions. It means that the complex is CONH3 whole 6 and there is Cl3, right? That is, this is present as ionic, it is present 3 moles of chloride are liberated. It means what? All the Cl, that is all the chloride are present outside the complex. So your formula is this. Had it been 2 moles of chloride being liberated, it means there is 2 moles of chloride are present outside, right? So this is the way we can find out. So what is the formula of the students? What is the formula of the complex over here? It is hexaamine cobalt 3 complex, right?